Hello. I wanted to make a little video about the idea of test-driven development. There were some people in our Reskill Americans Slack channel who were talking about testing, and I don't think it's ever too early to know something about how to write reliable software and how make sure it stays reliable and works as well. Nothing's perfect, but to try to catch bugs as early as possible and keep them out of your code base. So one of the things I actually learned kind of late in my career was this idea of test-driven development. And back in the old days, when I was first started at Microsoft, we had no testing whatsoever. We didn't even have testers hired. We did hire a lot of testers that did manual testing of things later on. But it came pretty late that we actually did something called unit testing, which is a unit test is another program which accesses the program you're trying to test, and it puts it through its paces. It tries different inputs. It tries, it could try a lot of different things, but just to make sure that the way that function is supposed to work is working properly across a number of valid test inputs or even invalid test inputs if you're trying to make sure that your code is robust against certain kinds of errors. So that's unit testing, where units are like individual functions or classes and things like that. You want to test each unit kind of in isolation. You kind of isolate it in a very well-controlled environment. You control all of the things that it sees, and hopefully, especially you want tests to be reproducible. You don't want your tests to go off and try to do an internet request somewhere random, and that could possibly fail. That will result in what's called a flaky test, and those can be the bane of your existence. If you have a big code base, a lot of flaky tests will make your tests fail kind of randomly. So you want reproducibility. So your tests run the same way every time. All the same inputs are given to your code, and hopefully they react. You verify that they are behaving the same way every time, the correct way that you specified them to be. So that's unit testing, and we'll do a little code sample here. I'll do some live coding where we will implement something using a philosophy called test-driven development. So what is test-driven development? It's kind of a philosophy where you write your tests first instead of writing the code. Now that seems nonsensical. How are you supposed to write a test for something that doesn't yet exist? Well, what you do, it's kind of a back and forth scenario. The way I've learned it and practiced it sometimes is, and this can be taken to the extreme, and some people do extreme versions of this, and others, it could be a little bit more casual. But the basic idea is that you want to write tests as you go, because the thing you'd want to avoid is writing a lot of code that has no tests for it, and that code is just waiting to break. When not something else, or someone might change something else in your code base, and they don't know about your code. They don't know that maybe a function you're calling, you depend on some specific behavior, so they change that, and now all of a sudden your code is broken. So your tests are kind of like a guard, a sentinel that's standing by, ready to stop one of your teammates from breaking your code. As soon as he runs the tests for the whole project, they'll see, oh, I just broke that person's tests. And they can go figure out, like, oh, I didn't realize they were depending on this behavior of my code. So usually we have a rule that you're not allowed to check any code into the project if the tests don't you get 100% passing, so that keeps everyone working well together. People are taking responsibility for always having those tests passed. Sometimes tests can take a long time to run for really big projects, and then so code can get checked in that breaks tests, and then it gets maybe automatically rolled back, and there's all kinds of complicated systems that people have set up. But for our purposes, we just want to write some tests and get the tests run the tests in a way that we have a methodology for ensuring that we're writing tests that are necessary and then ultimately sufficient to specify the behavior of our program that we want. So one way to do this is actually kind of a game you play with yourself. It's kind of like playing chess against yourself. You're going to play white and black at the same time. So when you're playing white, you're writing your function and you're trying to, make your code work and add features to it and build it up until it performs everything that it knows how to do. And on the black side, you're trying to prove that code is wrong, that it doesn't handle all the cases. There are cases that it fails on, and that it's not actually going to pass the tests. So you bounce back and forth, and purists in the test-driven development methodology would say, write your test first. So you kind of don't allow yourself to wear the white hat and write any code until you have a test that fails. So it's kind of like proving that your code, you're not done yet. You prove that you're not done yet by writing a failing test. And then you go back to your code, you make that test pass. Just do the minimal amount that needed to make that test pass. And then you've got to think, okay, what else am I missing? What haven't I specified yet? And you try to come up with more tests that will demonstrate that your code isn't finished yet. So that's the idea. So I had an example of taking how about if we write a function called test number to English, and we're just going to pass in a number, and we want an integer, and we want it to write out like in words, in the English language words. So like if I sent in 345, I want the output to be the English sentence 345, as you would write on a check or something like that. So let's write that function, and we'll go back and forth using test-driven development until we can complete our function. Okay, so I have set up a little. Now, there are testing frameworks that are in JavaScript. I have used things called Mocha and Chai. Those are libraries which you may learn about later. But for the purposes of this, I just wrote a very, very simple couple of helper functions, test helper functions here. We have one function that will run a test, and you basically pass it a function that is a testing function, and its responsibility is to call this other function assert equal. That's the only thing I think we're going to use in our test. There can be a lot of different kind of conditions that you can say have to be true, but you use this function called assert equal. You're going to pass in a value that may be coming out as an output of the function that you're testing, and then you're going to also pass in what you expect it to be if the test is to succeed. And then you can give a name for this if you want to remember like what the name of this test is. So every time you call assert, as long as all of those asserts are true, and like those two things are equal, then your test will pass, and then it'll output something. So right now you can see, I'm just outputting it in the console of the browser. So it says passed 0 out of 0 tests, because I don't have any tests in there now. So that's our basic test framework. Very simple, but that's kind of very, very much like what other tests do. So I have a function here called run test that's just going to run all the tests. And right now we only have a single test called test digits. So I said we need to write a failing test. So first of all, we'll need a function to test. So let's just write a function. I'm going to say here, convert number to English language equivalent. Okay. Function number to English. Sorry. And that's a function. So let's not write anything more. I'm going to test digits here. So actually, I could have even a simpler function. I'm gonna call it test function. Yeah, I'll just call it test function. So test function. So what are we going to test? We have a function called number to digits. So first of all, we have to have a well, we have to actually import. We're going to import the function number to English, and these are called ES6 imports from number to number to English.mjs. Okay. So we are going to assert that we get a string back. We pass in a number and we're going to get a string back. So let's say we're going to let our result equals number to English. We'll pass in the number 1. And we are, now if I go look at the browser, you can see there's a function called typeOf. If I put in a string there, it says the word string. So we're going to assert equal that our result, or the type of our result, is a string. And I'm gonna put a name here called must be a string. So if this test passes, it will make sure that we always get the right data type from the results of our function, or at least for this one example. But when we run our test here, you can see it failed. And it says the reason it failed is because undefined is not the same thing as string. So now we have a failing test, and that we give ourselves permission to go back over to our function. And what's the easiest way to make this function pass? And just return an empty string. And here we go. So now we are back in the black hat territory. White has finished adding some code, and now all our tests pass. So now it's our job to prove that this thing is not working properly. So let's put all the digits like from 0 to 9, and make sure that those work. So I'm going to run another test called test digits. Okay, so I'm going to say for let I equals 0, I less than 10, I plus, so all the digits from 1 to 9, and I'll have the result equal number to English of the variable I. And now what am I going to assert that these are equal to? Well, I want it to be the names of the strings 1 to 10, so 0 to 9 rather. So let's just break an array. We'll just write them all out. So I'll have I'll just call this answers. There's 10 of them, and we're going to have an array. Actually, I don't even need that. Actually, answers. And it's, oh, sorry. So, 1, oh, sorry, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's it. Those are the answers we expect, and we're going to say assert equal that our result is the same as answers of I. Oh, look at that. My test is really failing now. The empty string isn't equal to any of these things. Okay, so now I give myself permission to go back and implement something over here. Well, I'm probably gonna need all strings for all the digits here. So I'm gonna create a digits array here, which is the same. Actually, it turns out to be the same thing as my test has in it. I'm just gonna cheat here and save myself some typing. Copy this in here. Now I might make a mistake in both files, in which case my test has failed. Well, there's kind of nothing to be done about that. But so here is here's our list of digits, and oh, I didn't even take an argument here. So let's say I'm going to take a value n as a result, and let's see. Well, I can make this work by just returning digits of n. I bet that would actually work if you pass in the number 0 to 10. Look at that, boom. Now we have a working function, 0 to 10. So let's write another test. Like let's try some bigger numbers. Test let's say test two-digit numbers. And I don't want to have a whole bunch of them. Let's just do a couple of samples. Test 2 digits. That's our function test, and let's say we're going to assert equal that the number to English of 11 is 11, and we'll say maybe assert equal. Let's do a few different things on the range of things. It's going to get some variability of things. Let's try 21. Say that should be 21, and number to English 99. Say 99. Okay. And we write that out, and what do you know? Our test is failing. Oh, and it's even coming out undefined. It's like not even a string anymore. So yeah, that's bad. And so what do we do about that? We can go back to our test. And say, well, that the string is wrong. It's not even a string, and it's returning the wrong thing because it's overflowing this array. And so we've got to handle this now. So how would we handle two-digit numbers? Well, there's kind of like two cases in English. All the cases 11 through 19. I'm sorry, 11 through 19. They're all like single words. So we're probably going to have to do that as a special case. So we need like another array. So we're going to have the teens, and these will be the numbers from. Well, we can actually include. Yeah, do we want to include 10 here or not? I'm not sure. 10, 20, those are all like the decades. So I think I'm going to put that in a different list. So the teens are 11, 12, 13, 14, 15, 16, that's it. Those are the teens. So, yeah. Yeah, and then we'll have this thing which for the decades. So we're going to have 10, 20, oops, 10, 20, 30, 40, 50, 60, 70, 80, 90, that's it. Oh, not 90. All right. Okay, so what do we do? First, we're going to have to pull off the, we'll need the, we'll say if it's, if n is less than 10, then just returning this is going to work. Then we're done. So now if n is greater than 10, it might be one of these other ones, but if n is less than well, actually, if n is equal to 10, we're going to return 10. Maybe this is a little sloppy right now, but I'm just doing something minimal. And if n is less than 20 now, so now it has to be, 11 to 19 to fall into this category. We can just return the teens of n minus 11. That's where we were before. So let's see how far over our test got in this. Great, only 22 and 21 and 99 are not passing anymore. So for everything else larger, we need to pull off the decade number and add it to the digits number. So what I will do is let's say let the decade, ooh, what is that? I'll just call it, let the tens equal we're going to use a function called math.floor there, and which says it gets a number. We're going to take n divided by 10, and that's going to give us the 10 spot. So it'll give us how many tens it is. And then we're going to then let the units be n minus 10 times the number of tens. So we subtract those off again. So now we have the tens and the units. And now you can return, let's see, the tens part is going to be the decades. That is the tens now. I'm going to have to do tens minus 1 because this tens number is going to be either 1, 2, 3, 4, 5, 6, 7, 8, up to 9, whereas our array up there is starts at 10. So 1 is supposed to be 10, so we have to subtract 1 because arrays are 0 based. And then we're going to add the units, which are just the same. Oh, sorry, it's just digits of units. I think that's it. And look at that, I forgot a space. So now I ran my test, and you can see very clearly what's coming out. 21, it's 21, but there should be a space in between there. So let's just put a space in between, and there we go. Now our tests are passing. So, all right, I just thought of something I think this code is not good. It'd be nice that we finish off this example with if we believing that it works from 1 to 100 or 0 to 100, and I don't think we are working that way. So let's go back to our tests. And what did we have here? We had 21 and 99. One case I think we're missing is something that's like even a number of tens. So let's assert equal number to English 30. And that is supposed to just be 30. And let's see how that runs. There we go. Our code as written says 30. Well, that's wrong, and let's see if we can just fix that. The easiest way to fix that would be to have probably a special case here. I'd say if units is equal to 0, then we're only going to return the decades of tens minus 1. There we go, because we don't need that part. There we go. That works. So anyway, okay. So that's probably, well, I think it works from 1 to 99, and it would be, there'd be a lot more tests to add to something like this to really feel confident that it's working for all those cases and to go on up into the thousands and millions and things like that. But I will leave that to you. Maybe you could want to extend this even further. I'll try to share this as a GitHub repo. You can play with it from this starting point. Okay, bye.